All right, let's go ahead and solve this challenging problem, I should say, from the Singapore Math 7, Chapter 6, Section 3. This is a several part speed, distance, and time problem. It requires quite a bit of thought and setting up of different parts of the problem prior to actually solving it. So let's go ahead and get started. The first thing that I want to show you is that fancy triangle that we had where you can actually see all of the formulas that you need prior to actually solving the problems. So here we go. The first part we have here is distance. Distance goes on the top. Oops. Distance goes on top. Okay. And then we have speed and we have time. So remember, when using the speed distance or distance speed time triangle, we need to make sure that we set it up correctly and we know how to use it. Instead of memorizing the formulas, we can figure out some sort of quick mnemonic or a set of words to help us remember how this triangle is set up. And when you remember how the triangle is set up, it helps you figure out the three formulas without actually memorizing them. So maybe you want to think of, starting at the top of your triangle, donuts smell tasty, or don't stop trying, something along those lines, so that you are remembering where they go. So really quickly, in order to use this triangle, you need to use your thumb to cover up the part that you're searching for. So if we were searching for distance, we would cover up distance. Boop. And what would be left would be speed and time right next to each other. When we have two variables right next to each other in math, that means that we multiply them. So in order to find the distance, which is unknown, which is why we covered it, we need to multiply speed and time. I know we multiply them because the S and the T are right next to each other. Do you see why it's so important to make sure that you are setting up the triangle correctly? So if you remember or create some sort of phrase to help you remember the order, distance on top, then speed, then time on the bottom, then you'll be able to have all of your formulas correct. If, however, you end up putting something other than distance on the top, then all of your formulas will be wrong. So make sure that you are remembering this correctly. Let's start using it. All right, so Jensen Beach is 30 kilometers from Jupiter. Mrs. Walker ran 15 kilometers an hour from Jensen to Jupiter. On her return from Jupiter to Jensen, she ran 12 kilometers an hour. Find the average speed of the whole trip. So here's what we're looking at here. We are looking for speed. We're looking for speed not of one part of the trip, we're looking for speed of the whole trip. So if I came down to my triangle here and I got rid of speed, I would know that I would need the distance divided by time. So I'm actually going to write that next to our problem. Speed equals, I'm going to put my S back, distance divided by time. All right, so that's our main goal here, but we need the total trip speed. All right, so here we go. In order to have the total speed, we have to have the total distance. How do we figure out the total distance? So we can draw a picture. Maybe we want to go from Jensen to Jupiter. I know that was how long? Well, let's go back to the text. Jensen Beach is 30 kilometers from Jupiter. How far? 30 kilometers. I'm going to put a D over the top of that, and I'm going to label it in green because green is the color I'm using for distance. I know that that is going to be 30 kilometers. All right, let's go down to the next sentence. It says Mrs. Walker ran 15, okay, so kilometers per hour. That is a speed. I'm going to come back to that. From Jensen to Jupiter. On her return from Jupiter to Jensen, she ran 12 kilometers an hour. Kilometers an hour, again, is a speed. It reminds me of miles per hour, which is what we would use to measure how quickly or how slowly, really, you were moving in a vehicle or on a bicycle. So kilometers is just another way, km here, kilometers, is just another way to represent a distance. And when it's per hour, we're talking about that speed that's being covered here. Okay, so this is only a one-way trip here from Jensen to Jupiter. Mrs. Walker went 2 different ways because she did end up going back home from Jupiter to Jensen. So if I want to know what the distance is back, I need to think about what the distance was there. If I walk from one side of the classroom, from the back of the classroom to the front of the classroom, and it is 10 yards, then when I am walking from the front to the back to turn around and go back the direction I came, the distance is not going to change unless there is an earthquake that has separated the classroom and made the distance longer, or a sinkhole that has made the distance shorter between those 2 points. I'm still looking at the same amount of space. In this case, we have heard of no natural disasters that have changed the distance, so we do know that it is the same exact measurement of distance between Jensen and Jupiter. If I'm going from Jupiter to Jensen or I'm going from Jensen to Jupiter, it's still going to be 30 kilometers because the distance does not change here. All right, so if I want the total distance, sorry, my handwriting is terrible on here. I need to put together the distance of trip 1 and the distance of trip 2 together, combine, add. 30 plus 30 is 60. She has gone a total of 60 kilometers. Super important. I'm going to circle it. So now I have the total distance. Let's go back to our formula up at the top. Remember, we are looking for distance over time. Woo! Time. How much time did it take her? If you go back to the problem, there is not one time that the problem mentions how long it took her. That is a problem, which means we actually have to use the distance, speed, time triangle to figure out how long it took her to move from Jensen to Jupiter on the first trip, and then from Jupiter to Jensen on the second trip. So I literally have to do additional work here. So let's look for total time. Time is blue. Oh no. So I need, the total time would be trip 1, the time of trip 1, and it would be the time of trip 2. This is a very extensive problem here. All right, so I'm coming over and I'm looking for time. If I'm looking for time, that means I cover up time on the distance speed triangle. And that means that I'm literally going to be looking for time. And that's going to be your distance over speed. All right. So let's go ahead and try to set that up. For trip 1, we are looking for the time that it has taken Miss Walker to go from Jensen to Jupiter. All right. So, time from Jensen to Jupiter. Let's go back to the problem and look. Mrs. Walker ran 15 kilometers an hour. Ooh. Okay. From Jensen to Jupiter. What's the speed that she went on the first trip? First trip here. Boop. Everything in this sentence is first trip. What is the speed that she went? Well, it tells us she went 15 kilometers an hour. Remember, when we say kilometers per hour, that's really similar to saying miles per hour, and that reminds us of speed. All right, so 15 kilometers an hour. Speed goes on the bottom. I can see that because of my formula. All right, let's look at the top. I'm looking for the distance according to the formula over here on the right. I'm looking for the distance still. So the distance would be the amount of the measurement of space that she went from point A to point B. Well, if we went back to the problem, the very first sentence tells us that in green. She went from Jensen to Jupiter. Well, how long was it? Or what was the distance between Jensen and Jupiter? It was 30. So 30 kilometers divided by 15 kilometers an hour is going to give us the actual time here. All right, so trip 1, the time is 30 divided by 15. 2 hours. All right, I know that it took 2 hours here. All right, the next part, let's look. We want to look at trip 2. So trip 2, we have to do the same thing. We are looking for the amount of time that it took her to go from Jupiter to Jensen. So in order to do that, we need the same exact formula. When we cover up time on the distance speed triangle, we are looking for distance over speed still. All right, so here we go. The distance from Jensen to Jupiter. How do I know that I'm looking for that? Because it says on her return from Jupiter to Jensen. Well, what's the distance between those two? We come back and we look at the very first part of the problem where it says those two places are 30 kilometers apart. Same distance when we're going backwards. 30. So we're looking for the time here again. It's 30 kilometers. Okay. Now we need the speed. Let's go back and find the speed. She ran, on her return from Jupiter to Jensen, she ran 12 kilometers an hour. Wow. All right. So she slowed down a little bit, probably pretty tired at this point. She's already been running for 2 hours. Who knows what she did while she was there? We are going to go ahead and write down that speed. Kilometers per hour here. All right, so remember we have to divide. We can divide 30 by 12, and we already know that 12 will go into 30 at least 2 times when you write it out. We know it'll be 2. It's 24. We subtract. You end up with 6. We add a decimal and bring down our 0, 2.5. You could write that as a fraction if you wanted to, which would be 2 1/2. I'm actually going to keep it as a decimal. Okay, so 2.5. I'm going to circle my 2 hours from the first one, circle my 2.5 hours from the second one, and now I need the total time. What is the total time? The total time is 2 hours plus 2.5 hours. 2 plus 2 is 4. And we have 0.5 left over to add on. So 4.5 hours is the total time. Now, we are almost done. We need the average speed because that is what our problem was asking for in the first place. So I'm going to go ahead and I'm going to circle the information that is super important, our total times and total speed. Total distance here is 60 kilometers. Our total time is 4.5 hours. Now let's go back to the speed and distance and time, distance, speed, time formula that we had. Remember, we were looking for, according to the very end of this problem, the average speed of the whole trip. We now have the total distance and we now have the total time that was taken for these problems. Wow, that was a lot of work to get that. So I'm going to actually erase all of this so that we can figure out what's happening as we find our total time. All right. Or speed, excuse me. Our speed, average speed. All right, here we go. I'm going to rewrite my 4.5 up at the top, and then we have some room to write down on the bottom. 4.5 hours. All right, so what we're doing, remember we are looking at this formula up here on the top right. We are wanting our speed, and that is going to be our distance over our time. Let's rewrite. Speed equals distance, which is in green here. Our total distance is 60 kilometers, and our total time, because we need it over time, is 4.5 hours. When I set this up, I'm actually going to do it over here on the right. So we have 60 divided by 4.5. In order to do that, I have to move my decimal point right here. I'm going to move that over, which means I need to create a decimal and move it over also. So our new problem is actually 4.5 because we had to move our decimal. 4.5 into 600. All right. Oh, excuse me. That's incorrect. 45, because we moved our decimal. Sorry about that. Into 600. All right. How many times does 45 go into 60? I know that it goes in one time. We subtract 45, you end up with 15. We bring down our 0, which is 150 now that we are looking at. And if we are doing 45 into 150, I know that that's going to be 3. If I'm thinking of 45 kind of like 50, and I were counting by 50s, I know that 50 would go into 153 times, so 45 is probably going to be the same. I can try it over on the side just to make sure. So I'm going to say 45 times 3, and I know that that is 135 when I multiply it out. So 135, subtract, we end up having to borrow, and you are looking at 15 as your answer here. I need to put in a decimal, and now I can go ahead and add a 0 and bring it down. I am here again with 150. My option here is that I can go ahead and continue this problem the way that it is, or what I could also do is go back a step and write it as a fraction. That's totally up to you. You can continue going. This is one of those decimals that's going to keep going and going and going and going and going. So instead of putting a new decimal in, I'm just going to write what's left as a fraction. for my remainder. Whoops. Ah! And so what's my remainder here? My remainder is 15 over my whole, which is 45. If I reduce 15 over 45, I can say that it is 1 over 3. So my final answer would be 13 hours, 13 kilometers an hour with an additional 1/3. So 13 and 1/3 kilometers in 1 hour. Wow.